Speech to text has many use cases in Python. For example, for automatic speech recognition, real-time translation, accessibility, even so many virtual assistants which we use today. In this notebook, let us see how we can easily create such a system, and we'll have a working Python code. This notebook you can run on a free version of Google Colab, so you don't have to pay to run it. The free GPU resources which you see here are enough to load and run the models which you are going to test today. Starting with, we'll simply use torch and transformer libraries and we'll create a pipeline. Since we have access to CUDA in this notebook, we are going to use the CUDA device. We are going to use Whisper model. Whisper is developed by OpenAI's state-of-the-art speech recognition model. It can actually translate from many different languages and can do real-time transcribing, recognizing services. Today, we are kind of going to see how it works in English language. We're going to create a pipeline of automatic speech recognition. This pipeline is what we directly imported kind of from transformer libraries. Many of these abstractions are available from Hugging Face, so they do kind of make the life much simpler. The model which we are going to use today is OpenAI Whisper-based model. Many different variants are available. I'm going to show a working system which actually does really good. Before we proceed further, let us look at the model and see how many parameters it has. So if you print the parameters in the model, we roughly have, say, 72 million parameters. It's roughly 72.5 million. So it's a reasonable enough model. General overview, how this model works is, you might know that audio data set has very high sampling frequencies. So working in the raw space is often very challenging. We often work in a transformed space like male spectrogram space, which is a very common representation which we use in audio. It's a time frequency representation and it's a compressed version, but it kind of captures enough information for us to understand what the audio actually means. The architecture of this model is encoder-decoder architecture. So it kind of works in a sequence-to-sequence manner where decoder predicts the next text token. And it also understands the context, means it generates coherent sentences. Further, I think important part is that this model kind of generates text word by word, so it has a vocabulary. There's different ways kind of you can create models which can generate character by character as well. So different ways to model this problem. Today we are going to kind of use the transformer encoder decoder architecture of the Whisper itself directly, which is a pre-trained model available to us. To play with some audios, we are going to use VoxPopuli, which is a large-scale multi-speech corpus representation learning data set. And this is actually collected from European Parliament for different event recordings, which were done from 2009 to 2020. It contains kind of this transcribed speech as well. So it has many different languages, different accents. We are going to load English version of this data set. And I'm going to do kind of lazy load. So it's a large data set. We don't want to download the entire thing. We will kind of use only what samples we are going to say we are interested in. Different features are available. We'll be mostly interested in audio and the raw text. And since we are going to download on English language, so let us see what it actually does. First, let us actually look at how this data set is. So this is kind of audio of the data set. It's a WAV format, and this is what actually has been spoken. Like many measures have been taken, not only in September, but also in March and so on. There are 3 different samples which are visualized. We can actually listen to this audio. For example, the first sample, we can listen here for the first few seconds.
Many measures have been taken, not only in September, but also in March.
So you get an idea, like it's a 15-second audio. We can also plot these audio waveforms actually to get a visual feeling. So in the time domain, we actually will see the amplitude, and this is a very high sampling frequency in the data. This kind of very high amplitude which we actually visually see. Model actually doesn't work in the time domain, so we do extract kind of spectrogram out of it for the model to train, which is more like a 2D data form. These are first 3 kind of first few audio forms for us to visualize. Finally, how to kind of do text translation. Text translation is very easy here. I'm going to install some other library as well for us to do word error counts to kind of measure how good or bad our translations are. Word error count is kind of one of the metric which kind of helps to measure accuracy of speech to text models. It's one of the very widely used one. Basically, when model outputs kind of, for example, words, we try to find errors basically, and these are different ways we can define errors, like substitution, deletion, insertion. Based on the number of errors, we define the word error kind of count or word error rate, kind of like the metric name is word error rate directly. Further, for example, when the word error rate is like 22%, it means 22% of the words were either wrong or missed or extras. Now let us see how the translation happens. So translation, we directly put our pipeline the audio from the sample, kind of how many tokens to transcribe and all, and it's a task which is kind of a translation task. We have to pass that pipeline like what kind of task we are doing. Further, we will compare the whisper transcription and the ground truth as well. I will see the word error rate. We are going to kind of create an iterator or an English data set like the one which we lazily loaded, and let us try to transcribe the first sample from this data set. We already kind of have seen and heard earlier that this is the ground truth. Many measures have been taken, not only in September, and actually this is the whisper translation. You see, model does actually fairly well. It misses the comma and it misses kind of full step. Of course, like during speech time, many of these punctuations are a bit hard for model to capture, but otherwise it's doing a very fairly good job. Let us look at, for example, the second translation. Let me run it again. This is the second sample from the data set. In the second sample, again, we see the model is doing quite reasonably well, actually. We again have a very low word error rate and so on. I think this kind of clarifies how easy it is to set up audio to text translation pipeline with the help of open source models. And I will share the link to this notebook in the description of the video for you to follow along and use this in your projects. Hope to see you again in another video in the future.